So that's a nested iteration join, and I'm going to tell you that most of the joins you're going to see are the nested iteration joins. And as a result, what you're going to find is you do a lot of tuning for those nested iteration joins. You want to make sure that the inner table has a matching index, that you have the ability to join in multiple directions based on which table the search argument is going to be applied to. And honestly, if you're applying search arguments to both, make sure that you're indexed to join in both directions and have those search arguments either included in as or part of the index, because that will also speed things up significantly. Now, on to hash joins. Once again, I'm going to talk through this piece a little bit faster because you want to avoid the hash joins. The idea behind the hash join is we don't have a matching index. In the olden days, which is to say SQL 2000 and prior, what the optimizer would do is say, you know what? I'm going to build an index on one of the tables, and I'm going to leave it there for the duration of the query, and then I'm going to drop the index. As you can probably guess, if you have a largish table, you have the cost of building an index on the table and then discarding it, as opposed to the cost of building it and keeping it. That was one of the cool things that SQL Server 2005 did, was they added the ability to keep those indexes around. It may have happened in 2000, but that's what those underscore WA indexes are. They're indexes that were built on the fly because the optimizer said, you know what, I'm just going to keep this around because I seem to be using it a lot. So what the documentation says is that the hash join takes one row from one table, it probes the other table for rows that satisfy the join. I can't find documentation anywhere on what probe actually means or how that works. However, the documentation talks about hash joins, grace hash joins, recursive hash joins, and a fistful of others that we honestly don't want to have to deal with. So we'll talk about the fact that we can do it. We'll talk about the fact that we may get bad join orders. But what you really need to do is, if you have two data tables which are indexed or not indexed and using a hash join, add a good matching index. Here's the example of what you see when it says hash join. Here's the really interesting piece of information. I'm joining from table A to table B. The cost of the table scan of A is 17% of the query. The cost of the table scan of table B is 15% of query. The cost of the hash join is twice the cost of the two table scans. This all by itself should tell you want to avoid those hash joins at all costs, at least if performance is important to you. Let's talk about merge joins. The idea behind the merge join is that both of the things that you're joining, it says both inputs because they're not necessarily data tables, they might be derived tables, might be table variables, but both inputs are sorted on the merge columns. What the merge join does is it walks through each table, gets a row from each table, and compares them. This allows us to walk through each table once and have a single scan through each table as opposed to multiple scans. This tends to be the most efficient type of join. The stars do kind of have to line up here in order to make this work. Although frequently what you'll find is that if you take advantage of index covering, we talk about that in the indexes presentation, index covering can increase the number of merge joins you're doing and suddenly make specific types of joins dramatically faster. Note that the merge join can be used with a variety of types of join, from inner, outer, semi, union, etc. Once again, we just require that the inputs be sorted. So, on to our next topic. I have to talk a little bit faster because I've only got about 15 minutes left, and I do want to leave myself room for questions. Overriding the optimizer. In the past, when we put this together, we always had examples of when we could properly outguess the optimizer. And what we found was that with each new release of the server, and remember we wrote this back in the 6.5.7.0 days, the optimizer got smarter and our suggestion didn't work. In fact, I I was getting a little paranoid that somebody from Microsoft was looking at my class saying, Jeff found another one, let's fix it. And honestly, that's fine with me. If they're going to make the optimizer smarter, I'm very happy with that. But what it means is that it's harder and harder for me to come up with an example. And so finally, around 2008, I stopped trying. We talk about how to outguess the optimizer and how to force the join order when, in fact, we want to or need to do it. First thing to be aware of, outguessing the optimizer is difficult. If you're outguessing the optimizer, chances are your statistics are out of date and need to be updated. I strongly recommend updating the statistics first. Next, if you're outguessing the optimizer, you may be using something in your join operators or search arguments which are making it difficult for the optimizer to use the indexes. Frequent examples, putting date functions around a column. Great way to make the optimizer completely unable to use the index properly. It's got to guess. So as far as the join orders go, we can force the join. We talked about how to force indexes in that previous webinar. Here we're talking about how to force a join order. We force the join order with the set option, set force plan on. When we set force plan on, what we are doing is telling the optimizer, join it in the order listed in the from clause. Note that the set option, like every other set option, will last for the duration of the batch. So after you set it on, make sure you set it off. Otherwise, you'll find that of the 30 queries that you've got in your stored procedure, you set this on for one in the middle, all the rest of them suddenly get bad. That's because it needs to be set back off. In this example, what we've done is we've taken a look at the query batches for both of those join orders that we forced. And what we find is that the first one, forcing it from titles to publisher. Here we have it from titles to publisher. Note that we didn't force an index, we just forced the join order. But in doing this, we've identified that it is about twice as fast to take one join over the other. This is an expected result. Sometimes it's twice as fast, sometimes it's 2,000 or 3,000 times faster, depending on how much you're joining and how well the indexes match.